Hello, Tom from Every Step Calculus, everystepphysics.com. This is a physics problem, but it was in a calculus test, and the reason is that the integral of the Hooke's law turns into be the formula for the work. And so then these professors put that in there to make you a genius at this stuff. Index 8 to get to my main menu. Let's work it. I'm already at work of a spring. We're going to choose that. Choose number 8, stretching the spring. You can press the number or you can scroll to it with this, in my programs. I like to press the numbers quicker. These are different programs, so then I might have stretching redundant in these areas for you to choose, so just keep working with it. There's stretching a spring. That's certainly more than launching an object, which the other choice was. And so we have, what are we given here? We're given mass and we're given the stretch amount, okay? And they, in calculus and physics too, these genius professors just use x as the stretch value. I say that's wrong because this is a vertical spring, and so that would be a y-axis term, okay, instead of x, but not in the usual professors' minds. So we're going to use x for the stretch, and of course m for the mass. Choose it my menu here. Here we go. Number 6, m and x. Okay, so we're going to use number 6. You have to press alpha before you enter anything in these entry lines here in my programs, any program, okay, that I design. It's the way the calculator makes me do it. Press alpha, and we put in 3.8 kilograms. I do the conversions for you. Who knows, they may give you newtons, or may give you pounds, or may give you ounces, whatever, just to trick you as if this stuff isn't hard enough. So kilograms, so we say do that for you. And then we're going to enter the initial stretch. Alpha 2.1 centimeters. Well, that's divided by 100, so you're going to 0.021 is the correct calculation term. I say it's okay. Number 1. And we find the weight of the object by multiplying the mass times the gravity, and it turns out to be 37.28 newtons. This is the only force on the spring, so this is the applied force also, right? And it would also be the potential energy in it, mgh, but so we want to remember that. And then we find the spring constant from Hooke's law. By using algebra, we put the k out in front, and force times the divided by the x, which is, here's the force, the weight of the mass divided by the stretch, turns out to be 1775 Newton meters. That's the spring constant. And for the work, we use the formula which is derived from the integral of Hooke's law. And so then we add the terms here. Here's the k that we just figured, and here's the stretch squared. Turns out to be 0.39142 joules. So we know we've answered the first one. What is the work? Okay, that's the answer there. Press this. We want a new problem now because we got more to answer in number B. We're still stretching the spring, except now we have the mass, but we got a new mass involved here. And of course they don't tell you that, but notice if you took this mass here and put it up here, you'd have a different spring constant with the calculations. So they're not telling you this, but they want you to use the same spring constant even though they want to put a new mass on there. Okay, so that makes a big difference in calculations. But anyways, we're going to choose mass and the K for the spring constant, number 5, okay? So we press alpha, we put in 1.5, 1.5 kilograms. I say it's okay, and the spring constant is alpha 1775. Oh, we gotta press enter here. Alpha 1775. Looks pretty good. Press OK. And we have the new weight of the object. You know, here 14.715 newtons. That's the force applied. And we use Hooke's law to find out, we're asked to find the distance, the new, how far will the spring stretch if you put a 1.5 kilogram mass on it? Well, it's going to stretch 0.00829. If they ask for centimeters, keep that in mind. You multiply times 100 here, so that would be 0.829 centimeters. You can do that, can't you? I think so. So now we got a new problem. We're still stretching the spring, and you notice now they want us to put the stretch at 4 centimeters. Well, we got the same spring constant, right? So we got K and X somewhere here. Here's K and X, number 4. Let's choose that. Spring constant. Let's put it in here, alpha 1775. Say it's okay. And the new stretch is alpha 4 centimeters, number 2. And I say that's okay. So the work is going to be 1.42 joules after we enter it into the work formula. So we found that, and now we're done with the, probably go back to the main menu, whatever. Okay, pretty neat, huh? everystepcalculus.com. Go to my site, buy my programs, and pass calculus. I'll help you also. You can call me on the phone and I'll help you with problems. You can send me your quizzes. I'll show you how to do the problems with my fabulous programs on quizzes. And you'll have these in your calculator for life. And of course, you know, you're going to get out, if you're young, you're going to get out and get your job and stuff like that. Next thing you want to get a different degree, so they're going to give you business calculus, and you'll have all this in your calculator ready to go, etc. And same thing with physics. So enjoy my programs. Go to my site and purchase them. You'll never go wrong doing it, okay? Have a good one.